You have to tell me if that disappears as I'm clicking around, if you wouldn't mind.
Now, would the question change if instead of exactly it said at least? Or
Yeah.
would it just be like the same?
No, it would be different. It could be the same and different, as in, let's say I said at least 3 heads. Then I would do like the probability of 0, 1, and 2. Then minus that off like a total off of 1. Does that make sense? Now we're gonna get into this like this morning. Is what if they want the probability between 20 and 30? Right? The long way I could do that is I could go do that equation for 20, 21, 22, 23, 24, 25, 26, 20, all the way 30, then add all those probabilities together. But we don't want to do that. So we're going to have a flashback to previous knowledge. So you can do, what do you need fraction button for? No, that's a combination. 60 choose 20. Right? There's no line between it, right?
Yeah, you're right.
0.36, not 36. Like I said, 36. Okay? I don't know with that one. No, Dante did. No, Dante did. She borrowed it last time. Am I right? Where's your calculator gone?
Every single time I leave for a week, it's gone.
Did you leave it here? Okay. I got this first part. Okay. So, what if we wanted the probability of tossing between 20 and 30 heads in 60 tosses? Right? This one here is really good for finding like 1 or 2 or 3, correct? It's pretty easy. You can run the numbers somewhat quick. But if we wanted to do this, we'd have to do the probability of x equaling 20 plus the probability of x equaling 21 plus the probability x equals 22 dot 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 probability of x equals 30. Right? I don't know how many people want to do 11 sets of those. Right? Oh, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There's 11. No. Okay. What we could do is we could flash back to this, our Z-score. Everyone's so excited. Fair coin that flips 50-50.
You can get a fair coin?
Yeah.
Would it just have heads both sides?
No, it's just a little bit weighted, so it's going to flip. It's going to end up on one side more than the other side. Right? I was going to say your grandpa probably had. My grandparents cheated like SOB, so they'd have something unfair to trick you with. Never played cards with my grandma. So here's the question. Well, there's 2 parts here, right? And we're going to get to. So we could use the Z-score because you'll get, like if I flipped a coin 60 times, there's going to be some times where I get a low number of heads, sometimes where I get a high number of heads, but it's going to be one of those normal distributions. Does that make sense, everyone? So what we can do is we can figure out what we want And we could either cut off here using a z-score and use the probability like that of what that is. We could, like if it goes up to 100%, we could use the probability of what that goes. Instead of doing something 20, 30, 100 times, we could use z-score to find it. Okay? I know we're all so pumped again about this, right?
How are we supposed to do that though?
Good question. We don't know how to find the mean, right? We don't know how to find standard deviation. And we know what our, approximately what our x is.
Because we have none of the information.
Yet. But thankfully someone gave you a notes to self sheet that kind of has it all put together. All right. So let's go through here. Jesus won't help you here, son. Or he might. If he shows up and helps you, 100% in the course. Okay? Here's our formula for our mean. Can everyone locate that on their notes to self? Is it there?
Yep.
If you remember x with a line over it means mean. Okay? So you might want to write that in there, like write mean, right? Even write kind of when you, I may make a note to the side that says like approximation of probability maybe, just so you know when to use it.
What does that mean though? Like how do you know when to?
Well, when you use it, approximation of probability is when you're given like a range of numbers. Okay? So before, in the very first question, we were given one specific number. How many times will we get 20? Right? Or it might be a time where it's like less than 3, where I could do a couple calculations and figure it out. But this way, when you get this, it's a binomial, so there's 2 choices, right? Plus, I'm giving you a wide range of numbers, in this case, in between 20 and 30. So 2 things to recognize is binomial, which means there's only 2 choices, and a wide range of numbers. This is when you're going to use this strategy. So, what's the probability of flipping to get a tail? 50%. And what's the total number of trials we're doing? Which would be n. Okay? So you might want to put in there what n and p mean in your notes to future self. N is number of trials, p is probability of success. Okay? N is number of trials. P is probability of success. So for us to find our mean, we're going to take our number of trials and times it by our probability. So our mean in this case is 30, which makes sense. And this is our theoretical mean.
You did 0.5 because
That's the probability of success. So step 1, calculate your mean. Number 2, I'm going to write find, or calculate. Calculate the standard deviation. That's my worst standard deviation sign of the year. That's not bad. Did I put your standard deviation formula on there too? The square root of NP, which is realistically, did I write it as NP or the mean? NP? Okay. You could also write it like this if you wish. Because NP is just your mean, correct? And that 1 minus the probability is the probability of failure. Correct? So if you had like a 60% chance of success, then that's what we're figuring out. This is the probability of failure there. So this here now is the square root of 30 times 1 minus 0.5, which is equal to the square root of 30 times 0.5, which equals square root of 15. Oops. .87 is your standard deviation. That's not what I want to draw. If you remember back to the first week, deviation point so each one of these spaces is about 3.9 apart from the mean. So now this is where we go to our z-score. Okay? And if we kind of remind ourselves what we're looking, Hank tosses a fair coin, estimate the probability he will get tails less than 40 times. Okay? Oh, are you good? Okay. So now I'm going to go to my z-score. So step 3 would be z-score. So z-score equals x minus your mean divided by your standard deviation. And I'm going to leave it blank here for a second. And then we're going to discuss what we're going to put in there. Oops. But once we're done it, it'll make sense. Yes. Eat your croissant and get your butter. All right. So estimate the probability that he will get tails less than 40 times. X is not 40. Less than 40 times. You're almost there. 39.4. Well, rounding. Because we want to get as close to 39.5 as possible, because if you ended up with an answer of like 39.5, what would you do? You would round it to 40, correct? So we need to get close to, but if we end up with a number 39.4, we would round down. Well, because we want less than 40 times. Okay? So if we ran this experiment a ton of times, right? Less than 40 times, you want to come out with a number that is 39.4. Because if we had an experiment that we ran 100 times, it came out to 39.5, that could get rounded up to 40. Okay? So you kind of got to just be aware of those, like your range numbers. Okay? And this will give us a z-score of 2.43.
I'm sorry, what? I got 31.6.
39.4 minus 30. Press the equal sign. Because what you did was 30 divided by 3.87. 39.4 is because we want less than 40. Because if you think about it, if you ran an experiment a whole bunch of times, right? And you wanted to bring it to 2 decimal places. If you ran an experiment and got 39.5 as your answer, what would you do with that number? You would round up to 40. Since we only want 2 like this here is in 2 decimal places, right here. So that is why you go to 39.4, because if I want to round that to 2 decimal places, right? If you want to get more accurate, you could go like 39.4, I guess it'd be 444. That's as close as you get once you move any one of those up. But that's fine. So 2.43 is our Z-score. Now, how many people still have their Z-score table? Pardon? What was my number again?
It was 2.43.
2.43?
Yep.
So if I go to my Z-score table, which some of you may have in your notebook, 2.43? 0, 0, 1, 2, 3. There's our number, okay? So if I were to draw this out, right, there would be 99% on this side, 1% or 99.25, right, and 0.75 on this side. So how many, if we're thinking less than 40, we would get less than 40 99.25% of the time. Does that make sense to everyone? Well, if you think about it, if it's 50-50, right? Most of it, if I ran that experiment like 10,000 times, right? Being having a 75% chance of getting it would be 66% chance, whatever. Let me think here. Like being that far off, like the average that's how like statistically, that's how much off it is. Like 99% of the time, you're not going to get outside that range, right? We can run some coin stuff later and see what works out. Okay. So, shall we do another? What was that? You can always eat snack. No, we can't go for a body break now. We've only started a lesson. Oops. All right. So the one thing, and I'll research why this occurs, is you can only use this in certain situations. I guess we could call it the rule of 5. Only if the mean, the average, no. Well, step 4 was like looking it up in your Z-score. Only if this here, the mean is greater than 5, and this is greater than 5. You just have to test it right before you start. So we'll do a couple of tests here real quick. So does everyone understand? You guys got all that information from these 2 formulas, correct? In your notes to self? Did I put a check in there for these 2? Is there a box with check?
Check NP and N bracket 1 minus.
Okay, so they're both in there. Does it have greater than 5 in there? So write in greater than 5. Greater than or equal to 5 in that box as well. So pardon? Yeah, but you have this already in. Like you have the 2 formulas. Am I correct? Write in there a note that says both must be greater than or equal to 5.
Scheduled it on Friday, they're stupid.
I don't know. I'm staying out of this.
What's scheduled on Friday?
Virtual prom. No one's gonna go.
Maybe I'll supervise that.
But it's
You can
in school.
supervise
No one will be here.
So we're not.
I
I'm not asking anything. So.
Okay, here we go. So let's do the calculation here, right? Let's figure out if we can do the approximation using this data or this data, right? So if I look at NP here, NP equals, I need it greater than or equal to 5. 10 times 0.3, what's that going to equal? 3.
So no.
Do I need to do the second calculation? No. So since 3 is less than 5, therefore. You guys never use that? 3 dots in a triangle means therefore.
You never use that. Never use that. You write therefore.
I don't use the word therefore.
Their education system behind ours.
No, don't, shush.
You don't teach that in Nazareth.
She was there for like 2 years.
No, it's not Nazareth. It's Jerusalem.
I learned this in elementary school, so Holy Trinity must be flawed.
Hey.
Okay, there we go.
It almost has as many kids as this place.
Pardon?
More kids than Lewis VM. Lewis.
Oh, does it?
Imagine going to
Oh, I'll look it up then. Okay, let's do the next one. Can we use it here?
Yes.
So NP equals 14 times 0.5, which equals 7.
So now what is
Check. And then N times 1 minus P equals 14 times 1 minus 0.5, which also equals 7. Check.
So what does that mean? Is that the mean?
This is the mean right here, correct? But this is just like, these are two parts of the formula that need to,
Does this connect to
no,
this?
no.
So what's this?
This is making sure if these don't occur, you cannot use this strategy to approximate the probability.
Is it just using?
It's using parts of it, yeah. Yeah.
How do you know if you can use it or not?
How do you know if you can use it? You know you can use it if both of these numbers come out higher than 5.
Use it for what? Use what?
If you can, so if you want to approximate the probability using like z-score,
Yeah, that's what I'm like. So
Yeah.
you use this information to do that.
you use the n and the p values. So if you get a, here, I'll walk you through here. If you get a question, now, if you get a question like this, right? Or, for example, like we're about to do, okay? You first, before, like you realize if I were to read this question, calculate the probability that in 100 rolls of a fair die, 4 appears 20 to 30 times. So that tells you, A, I have a range, correct? B, it's also binomial. There's two things. Either it's successfully a 4 or not successfully a 4. Right? So now I know I'm going to try to use my z-score to estimate this range. For this strategy to work, this has to be greater than 5, and that has to be greater than 5.
In order to use the thing that we've done.
In order to do the steps that we used on the previous question.
Isn't it greater equal to 30?
So, don't worry about that right now.
So
Okay.
like that's how it connects. It's greater than 5.
Yeah, ours would be greater than 5. Like, I didn't show it to you first. I showed you like the concept, and then like here's the check you have to do.
But that's why we did it before. We could do it because it's greater
Yeah.
than 5.
So every time you get one of these questions, the first thing you do is do the checks. And if the checks turn out to be, now that'd be a super mean question, which would be kind of fun to put on. I could give you one of these questions that you could not do, And if you did the checks right away, you said, no, I can't use it, and move on to the next question. Right? But it checks your understanding, right? Now, hypothetically, to be a smart student, you look at the marks beside that question, right? And figure out if you're doing too much work or not enough work,
That's what I do in the test.
right?
Like 2 steps.
The number of strong.
Or I might not put on the marks next time.
Nice.
Like the probability.
I'll put them on everyone else's but Dante's.
Dante, I'll show you.
I'm gonna watch your mouth because there's more Montreal kids in here than there is the rest of the kids.
Bro, you know what you should do?
Gang up
Dante's
together.
test? You should
Huh.
get everyone, you can make Dante a separate test that just has all of the same questions except they're 49ers themed.
I'm not putting that much time into Dante.
Well, you did it with 2 questions on the board.
Yeah. Okay, here we go. So what's my N and my P here? What's my N?
You get a Skyrise apartment.
100. Shh. What's my probability of success? I'm rolling a fair die, a 6-sided dice. What's my probability of a 4 showing up? 1 over 6.
What are we letting X be?
Slow down for me. X, well, that's like 5 steps in.
Well, it just says let X. I'm like so confused why it just says let X be on the side.
Oh,
I don't know where you got one.
That's just for fun.
That's just for confusion.
okay. Let me move this down. I have a conclusion to ignore that. Because I'm more... Here, I'll let X be.
Oh, is that just for the solution?
Oh my god.
It's not erasing on my page. That's not typing on my page.
I look at you as I run. Bring a teacher that said that.
I just don't know.
I own a 3-bedroom apartment in Fisher.
What? I'm not really.
The 3-bedroom.
Just take my notes.
Yeah.
Did Jesse live in that house?
From the show Jesse. Yes.
Oops, wrong one. All right, so let X be the event rolling a 4, and we want between 20, equal to 20, up to equal to 30.
Tell me where you got 1 over 6.
6 numbers on the dice,
Oh, and you are one of them.
1 and 4. Yep.
Wait, I don't get
What's
why-
1 over 6 as a decimal place? Do you have it there?
Why is that signed that way? Remember you said they want each a bigger number?
Yeah.
1.6666667.
I don't get it.
Okay, one second here. 0.17.
Yeah.
Okay, this one here, treat it as different. So I want something greater, you read it from the X out, right? So greater than 20, less than 30. So I read this way and then that way. X is greater than 20, because it's eating the X, right? So it's greater than 20. Then less than 30, because it's eating the 30.
I still don't get it.
Okay. It's something that comes, yeah. I'll put on a shark video later.
I guess poetry is two different.
Alright. There's a really good shark video of like the, I'll show you later. No, we're, all right, let's check first. So 1, let's check. So our 2 checks are N times P, right? And N1 minus P. So 100 times 0.17 equals 17, and 100 times 1 minus 0.17 is going to be 83, if I'm not mistaken.
Wait, is 0.17 just
The probability here. Good. So Does it both our first things check out? That we can go forward? Unfortunately, yes. Dante was hoping for a no.
Wait, so the second number just has to be greater than the first?
So
No, and both of these have to be greater than 5.
It's 83 to
83.
0.83.
Because 0.83 times 100 is 83.
But the other one's 0.7?
No, it's 17.
Mine's a-
So if one of them is not greater than 5, you already
That's just on the
throw the
board.
question out. Let's just throw it out. See you later.
Pardon?
So if one of them is not greater than 5,
You can't use this strategy.
Okay.
So what would be the other strategy to that?
The other strategy, if you had to get the answer, you would have to do that probability, the binomial probability, for 20, 21, 22, 23. But I would not make you do that.
Thank you.
Okay?
You're very nice man.
We'll get there maybe.
Somewhere.
Okay, next thing we do. Let's calculate the mean,
Stuff that in there.
right? So how do we calculate the mean? What's the mean equal? N times P. And thankfully I already have that, don't we? Which is 17.
Well, so you pretty much find everything you need by doing
No, 100 times 0.17, right? It's not a hard process, it's a long process.
But like you find everything you need for the standard deviation right there, right? Like you find the mean and the number.
Not quite. Because, so standard deviation now? What's the formula for standard deviation?
Can I give you a Tesla?
Here's a Teslas for free and then comes
Okay,
one side
Dante,
and gets
Dante.
control for certain.
Do you guys understand how I got that number without writing
You don't define her.
the 0.83? 1 minus 0.17. Okay. Where are we here? So standard deviation should be 3.73. Pardon? Now we z-score, yeah.
It's so much easier than learning all the numbers and
A long time.
remember for standard deviation we used to look at a table.
Yeah. Different. But that was like experimental data, not theoretical. Same.
3.6.
We're all around the same area. Like, depending on the decimal places you used, you're in the same area. Like if you use 1 over 6 here as this, it's going to be more accurate, right? Yep. Now z-score, we're going to have to do it twice. Okay? Because we have a low end and we have a high end. Do you agree with me? On the previous question, we only had a high end. And it went from like all the way from 40 down to 0. But now we have constraints of 20 to 30. So our low end one here, z-score equals blank minus, what did I say? Yeah. She uses a different number than I do. 17 divided by 3.73. Okay? If I want 20 as my number that goes in there, no, not 19.4, but 19.5 because I need to round up. Very good. Okay? And my z-score, that would be, I'd be going from 19 to, oh, sorry. My fault. I was thinking of the next question over. Now, if I want my high to be 30, I'm going to write 20 in there and low of a high of 30. If I want a high of 30, What number am I going to write there?
29.5.
No. No. Say it, Cal.
29.4.
No, that'll give me 29.
It would be 20 something.
That would give me 30, but I'm missing something.
Can you tell it?
30.4.
Why do you rate 195?
Okay, you grabbed them.
Oh, okay, that makes a lot more sense.
19.5.
Why would you put 4?
Pardon?
Why isn't it put 4?
Because I want to round up to 20. Right? So I take whatever number I want to be at, I go as far as I can, like either away if it's low or above it if it's high. Okay? Now, this will give you, you're not getting the exact same numbers I am because I'm using numbers that are different. We're going to be a little bit off of the actual calculation because the sheet I'm using, she used 16.67 here, and we rounded to 2 decimal places.
So if you just add the numbers together and divide by 2?
Nope.
And the answer?
Nope.
Sure that would be 76?
I am 100% sure it doesn't. But I'm just going to use those numbers.
But don't
I
you
know.
just find one number?
Do you want to use 67 instead?
Yeah, why are you using
Okay.
the wrong number?
Because I didn't want to calculate it out right now.
You're
What'd you get? 0. Point.
0.67.
What's the other one?
3.59.
I use the numbers off the lecture sheet, but we did some different rounding in there. I'm not too worried about the exact number. I'm more worried about knowing what to do with the numbers.
I thought you could only have one number. Like, what, don't you have to add the 2s and 2s together and divide it by 2 to get 1?
Not quite. Once everyone's caught up, I'll go through it.
I got 3.59 for that 2,
Yeah, that's fine.
but you said you were using the wrong answer.
I chose to use the right answer. I'm not too worried about like the exact number right now, right? Because I'm using Miss Thornburg's lecture sheet, the kind of that note, and I did some other rounding that she didn't, right? I use 0.17 as my probability. For sure, use 0.1667, right? So before I go to the Z-score, let's do some visualization here. We're not going to all close our eyes and whatnot. Okay? So, where would you approximate a score of 0.16 occurring? So, remember, like low is here, high is here. Let's say that's 4. I don't know what the exact number is. So,
Standard distribution delta thing?
yeah, where would
34%.
no, but where would a Z-score of 0.67 land as I go across here? It'd be about here, wouldn't it? Right? And 3 point, let's do that. Let's do this. And this one's going to round about here. So the probability, we can't divide and get the average of those Z-scores because we're looking for, the probability is all this area included in here. Does that make sense? Once you kind of look at it? Yeah. However spaced apart it is, right? That's the probability you're looking for, is the probability between the two lines. In the previous question, we had 2 lines, but realistically, like this one here, the 2 lines were like here and the end. And that's what probability we found there. Where this one here, we have 2 lines exactly between. So let me write down our numbers, then I'll go 0.67 and 3.59. Question, Cal?
So like, find it. Do you not just like take the standard deviation off of both and subtract off like the total number?
No, but that's not our standard deviation. No.
Like, sorry, I mean like the offshoot, like the lower
Yeah.
number, and subtract it off the like the
Higher number. Yep, that's what we're going to do. Where are we here? Let's go to our Z-score. We have 0.67, right? So 0.67 is
Get back to me.
0.7, let's go 72, okay? And then our next number is 3.51. Oh, 3.51 is above 3.4, so it's 100%. Does that make sense? Since my highest number I can go is 3.4, right? Essentially, it's 100. So my other number is 100. So 72% and 100%. And then that's where we're going to find, I realize what I did wrong with my chart now. That would have been negative, that line there would have been negative 6.7. 6.7 is around here. So then we take the difference between those two, okay? So our two numbers were 100 and, what, 77%? What was our number? It was 100 and what? Because we use different numbers. 72? Okay. And 72%?
I believe that was what it was.
All right. Therefore, the probability, the number between there is, was that 28%? Right? Does that make sense?
So in between the two lines.
In between two lines. Now, I drew this line wrong.
Oh, so you just do the difference between everything.
Yeah, like this line's around here. Because I forgot there was negatives within there, right?
3.59 is 100%.
Correct. The z-score of 3.59 worked out to 100. The z-score of 0.67 on the chart was 72. The difference between them is 28. So the probability is 28%. It is like 0.28.
Or is that the probability?
Why did you drop
Probability.
it from 0.67 to 72?
Say that again?
That's the z-score. Like
Oh, yeah.
It's a long process. Not tedious. Tedious to me is like doing the same calculation over and over again. This is just a process.
Tedious right there.
No, it's tedious if you did the other way. Like if you had to do the probability for 20, 21, 22, 23, 24, that's the same process over and over and over and over and over again. Okay? I think I've killed Cassandra already this morning. Alright. Alright.
I think you're experiencing absenteeism.
So your homework is not as bad as you think for today. Hello? Not bad.
Loving this peanut, you guys? Woo!
Oh, I put it on a sheet for them already.
Do you have that?
Yeah.
Something similar? Okay.
Yeah, I built
Cool.
their sheet from that, and we're filling
okay.
in
Oh, right.
we're filling in the
Right.
their notes as we go through
Okay.
with those boxes. Perfect. They don't believe they're understanding it. They're doing fine.
They do. They will.
All right. So this question here, there's 4 questions that. Okay. I'm gonna let you skip. What I want you to do right now, before we go for a body break, which we desperately need. Okay.
If I do well on the test, I'm gonna discount the fat dog.
What did you just say?
I said if I do well on the test, I'm gonna discount the fat dog.
You're not in his class. You're not in her class.
Yeah, make a deal. Broker a deal.
Okay. So here's what I want you to do. These first 3 and 5 are actually binomial probability that we did yesterday. That's how you do those. Okay. Do you want to go over one of those?
My body's slowly deteriorating.
Oh my gosh. See, toughen up.
Look at me. Toughen up. Look
Okay.
Slow these down.
Physically, you can, Mr.
Okay. What I would like you to do, I'll do one of these questions with you first, but if you understand it, I want you to do. Like question 8 would be a good one to do, right? Or question 6B would be a good one to do. Let's do question 8. I'll help. I want to see you get question 8. Cassandra, I'd love to see you like work with someone, but do it up on a board. I think that might wake you up. Does that make sense? I think if you get standing, I'll ask you how your diet was this morning. You're fine? Alright.
With what now?
Just tired?
What was in the oatmeal?